Okay, good afternoon, everyone. Today we are going to learn about phonetic aperture radar. So, I think you might have learned about optical remote sensing or the basic of remote sensing by today. So let's first recall what is remote sensing. Okay, remote sensing actually is the science or is a technology of acquiring information about an object or about features on the surface of the earth without in contact with the with that object. Okay, so this is the concept of remote sensing, and I think so I will not go deep into that because other faculty also they have covered. So when we talk about remote sensing, we should also know about the electromagnetic spectrum. So, what is this electromagnetic spectrum? It is actually the light waves. We can imagine as ocean waves now, but here the waves here they are traveling at the speed of light. So, so there are different types of remote sensing based on this different portion of this electromagnetic spectrum. So we can see that there is radio wave, microwave, infrared, visible, ultraviolet, and then visible. Whatever the optical remote sensing works on visible portion of the uh, electromagnetic wave, whereas the radar works on microwave remote sensing. And then radar comprises of imaging and non-imaging. So, but for today's class, we are mostly concentrate on the imaging part of the microwave remote sensing, that is the synthetic aperture radar. So we all know we are from all science background, so we know about the wavelength and also the frequency. So I will not dig deep into that. So these are the radar parameters, and on the right, you will see that there is the different type of bands and the different type of wavelengths used uh, for this microwave remote sensing. And then the microwave remote sensing mostly use the X band, C band, S band, L band, and P band. And this KA, K, and KU, they are mostly used in military purpose. Okay, so some of the C band, like we have our Indian EOS-4, then we have Sentinel one, this, and then X band we have Terasat X. So different type of satellite they are using different type of bands, and then we'll come to the active and passive remote sensing. So we know that active and passive remote sensing, there are these are two different types of remote sensing. So in active remote sensing, we mostly have our own source of energy to illuminate the targets, like radar and then lidar. These are active remote sensing. Whereas the passive remote sensing, it depends on the energy of the sun to record the reflected energy from the surface of the earth, and then this reflected energy is recorded by the sensor of the satellite. That is, this is dependent only, or this is mostly works during the daytime, the passive remote sensing. Whereas the active remote sensing, it works both on during day and also during the night time. And then this is the difference. You can see the microwave or the optical remote sensing, and this is the microwave remote sensing. So mostly the optical remote sensing is affected by clouds. If there is a cloud, then the optical remote sensing actually don't perform as compared to the microwave remote sensing, because this microwave remote sensing, the microwave can penetrate the clouds. So there is no cloud effect. So So this is the advantages and disadvantages of microwave over optical. So as I told, nearly all weather capability, day and night capability, then it can penetrate through the vegetation canopy. Whereas the optical remote sensing cannot penetrate, only it record the reflected from the surface of the fissures. And then it also penetrates through soil, and then we can also have minimal atmospheric effect with the microwave remote sensing because of the large wavelength and then longer wavelength, and then it does not affect by the atmospheric scattering. So then the disadvantage of microwave is that it is different from optical, and it's difficult to interpret. Means sometimes difficult to interpret if we are new to remote sensing, and also it's affected by the spectral effect. Spectral effect I will come in later, and then it also affected by the topography. So when we talk about microwave remote sensing, there are two types of resolution. That is the range resolution and the azimuth resolution. Range resolution is the minimum, or the minimum details that the microwave sensor can identify, which is in the which are placed in the same angular direction, whereas the azimuth resolution is the minimum, or the closely spaced factors that the microwave can uh, that the microwave uh, can actually discriminate, which are placed along the flight vectors, means the motion vectors of the satellite. So means like I will show you. When the satellite is moving like this, so those objects which are placed along these motion vectors, they fall under the microwave remote, or they fall under the azimuth resolution, whereas those which are placed in this direction, they falls under the azimuth, or they falls under the range resolution. So that this is the difference between azimuth and range resolution. So actually the azimuth resolution, it depends on the it also depends on the length of the antenna. So with higher length of antenna, we will get the finer details. Means the resolution, the azimuth resolution will be very fine. So it is impossible to have a very long antenna in space. So that is why we have a synthetic aperture radar, where using the different image processing technique during the acquisition of image, they produce a very long antenna using the small actual antenna. So they are synthetically reproduce this length of the antenna. So I will not go up into much detail about this, the physics and all. So this is, so I will show you. So this is what I'm saying. That is the slant range. So this is the range resolution, whereas this part, you see this part is the azimuth resolution. So azimuth direction means along the track. It's along the track of the satellite. So here is showing like a spaceborne spaceborne platform, but we can imagine this might be a satellite. This will be a satellite. So the direction of the flight will be in this side. So this is called the along track or the azimuth resolution, and this will be the approach track or the range resolution. And then this is the how the penetration depth is depending upon the different type of band. So with I just thermal signal, like with increase in the wavelength, there is higher or deeper penetration of the microwaves. Then when we talk about the microwave remote sensing, we also have to understand the polarization. So polarization is actually the plane of the vibration of the electric field. So if it's vibrating while transmitting, because the microwave sensor will send signal towards the earth surface, and then it will receive it back. So when it transfer in vertical direction, means direct field is vibrating in the vertical plane and receiving also in vertical direction. So that is called the VV polarization. And then similarly the HV means it transmit during the or it transmit in horizontal and also it receive in vertical. Similarly, the PH it transmit in vertical and then receive in horizontal. So these are the different polarization that we can achieve using microwave remote sensing. So this is the radar backscatter. So how the radar backscattering mechanism. So when there is a smooth surface, every pulse that's reach the earth surface or any surface on the earth features, they reflected away from the they reflected away from the sensor. And whereas for a rough surface, some of the pulses they reflect or they backscatter towards the sensor. Okay, so the radar signal currently sensitive to surface structure. That's the reason. So smooth surface will have very less amount of energy to be backscattered towards the sensor as compared to the rough surface. So this is another. So this is called a double bounce. When the pulse hit the smooth surface, again it reflected back and then hit another smooth surface, which are vertical towards the first surface, and then it will reach towards the signal. This is called the backs or the double bounce. And there is from the vegetation layer, we from the vegetation we also can get the volume scattering. This is called the volume scattering. So this is same slide only where it shows different type of scattering. So this is radar image distortion. So in microwave remote sensing, the images suffer from distortion. So the first distortion is called the foreshortening, and the another is the layover. In foreshortening, suppose there is a hill or any steep object, the pulses that reach at the bottom, it's reflected first or backscattered with the signal first as compared to the pulse that reach on the top. And that the vice versa of this foreshortening or the opposite of foreshortening is called the layover, in which the signal reach for the top and then it backscattered towards the sensor and then it reach later at the bottom and backscattered towards the sensor. So these are two, and then another one is shadow. Shadow when it hit a steep object somewhere here, then it didn't illuminate this part. See, nothing is illuminated to this part. See, you can see this part. It hit the fissures here, whereas this side there is no signal. So there is no backscatter from this part of the fissure, and then this will appear as a shadow in the image, like this one. You can see this black thing. These are all shadows. So now we'll come to speckle. Speckle actually is a granular noise that appears on SAR image. This actually degrades the quality of the images. So when we talk about speckle, so there is a pixel in an image when a satellite sends the pulse towards the Earth surface, it actually uh, it actually record those backscattered energy in the form of pixels. And then within the same pixel, even if it's a homogeneous surface, the different, suppose if we take example of grass, different types of orientation or with even with the same type of features, different type of orientations affects the waves that falls on this particular feature within a pixel. So the difference in the difference in the reflected or in the backscatter creates the noise within this, because sometimes there is constructive interference and then sometimes there is destructive interference. So within the same pixel also there is different variation in the backscatter signal, means the time difference. When we say the time difference, so this time difference is also called as a phase difference, and because of this phase difference within the pixel, there is a constructive or destructive interference. So that is why the SAR image suffer from speckle. So here are some of the processing steps of Sentinel. So first we have the orbit file. We have to apply orbit file. Then thermal noise removal. Then we have border noise removal, calibration, speckle filtering. Then we have terrain correction and conversion to decibels. So this processing step is followed according to Filipponi of 2019. Based on this paper. So here snap will be used for processing of Sentinel-1 SAR images, and then different type of radar satellites. We have like our own Indian satellite US4. Then we have Sentinel-1 mission of European. Then we have RadarSat, TerraSat X, Panamax, and the future one will be NESAR. NESAR is NASA and ISRO mission. So this is future is not launched yet. So here I show that uh, the Indian constellation of all the satellites, not only the SAR, here optical, or even we have this inside 3D. All types of satellites are displayed here. So this is upcoming. I told you upcoming. I'm not talk about this. So some of the applications of SAR image in water resource, we can have water body mapping using SAR images. So in Google Earth Engine, we can just directly, because Sentinel-1 is available in Google Earth Engine, so it's all pre-processed, except we have to apply the speckle filtering. So directly we can use speckle filtering and we can analyze any type of analysis. So here we are using it for mapping of water bodies, and then the flood inundation also, like during flood, the most of the locations are covered with cloud, so optical remote sensing will not help us. So that is why we are using SAR image. So this will help us in mapping the inundation and taking the decision accordingly. So next one will be, next one also is inundation. So this is inundation mapping of Assam, in Assam. So we can see the flooded is in red, all the flooded areas, and then there is a permanent water bodies, all the permanent water bodies also. So we have to uh, exclude from the flood. Then we can use it for identification of embankment breach location using synthetic aperture radar. Also we can use map the embankment breach. See somewhere here there is a breach. So we map and we can identify this embankment breach using SAR data also. If the, because during the breach also it's monsoon time and then it's covered with cloud, so it's very difficult to use sometimes to use the optical remote sensing images. And then how to download microwave data? We can use Gunidi for EOS4 and for Sentinel also is available. And for Sentinel-1 we can also use Copernicus data ecosystem. So this two this two websites we can visit, and we can especially visit Unity, where you can download different type of images. Even Sentinel-1, Sentinel-2, List4 is available in Unity. So we can also, if you know Python, you can also automate the downloading process. So here I'm showing the distribution or the image of Sentinel-1 in Google Engine. So this is the availability of images. I mean, like for a particular date, I've done it for a particular date. So this is the availability for the Indian. See, this is India. This is our notice for the Indian region discovered with SAR images for a particular date. And thank you. So this is all about just an introduction for to this microwave remote sensing temperature radar. So if you have any doubt, you can, or else you can proceed to the hands-on. Okay, we can proceed to hands-on. For the hands-on, first of all, I will show you all the steps. So you don't need to do it just for recording. I'm doing. So I'll show you all the steps, what we are going to do. And then later that, after we complete that, we will start with the process. Means you will do along with me. Okay? So first of all, what we need to do is we need to download an image. So but for that I already give you one image. So I've seen one lab is there for downloading image. No, sir? One lab is there for downloading image later. So that one you will learn later how to download. I already give you the image for today's lab. Okay. First of all, we need to have an image, and then we need to have a snap software. This software is mostly used for Sentinel-1, for processing of Sentinel-1 image. So these two basic requirement, and then after that we can start our processing. So first of all, we need to create a folder. So I'll create a folder. Sentinel-1. I will add my image. Okay, I will show you. So you can go to file, open product. Then we can browse. We can browse to the folder where we store our image. Then open product. Then our image will open here. So you can also check your metadata here. So all the metadata of the images is displayed here. Okay, you can see and you can view all the metadata. After since we are going to process the Sentinel-1, which is radar image, so all the tools will available in here. All the tools will be available in radar. After optical, there is radar. So we can use all the processing from this radar. Okay. So first of all, we need to apply orbit file. That first step is to apply orbit file. So orbit file, and then you can click on do not fail. If new orbit file is not found, then you can run. So it will take time if I run. So I don't need to run now. It will take time if I run. So you can take time. Okay. Then we click on run. Now applying orbit file is done. So after it's done, we can remove the original image. Close product. Okay, right click, then close product. It will close the original image. Now we need to process further this file. So next we'll do thermal noise removal, which is available in radar, radiometric, and then thermal noise removal. We have to highlight both the bands, and then I'll change the folder. Then I will run. You can do according to the Here is working the cyber modern system. Recording is gonna be shift here, no? It is going to somewhat difficult. Try once it is not done there, then switch it. We will stop the recording. Understanding is important. Yes, yes, yes. Actually, he is working at the side. Try once. Ah, recording. Stop. Stop. If it is not going to work, tell me. Stop the record. Use your headset. I just experiment or more. If it is installation, it's not installation till now. नहीं हो रहा है तो कर लीजिए आप कोई दिक्कत नहीं हो जाएगा So okay, welcome back. I just sorry. a bit heavy, that's why. So, so it will work. Yes, sir. अच्छा फिर ना we have to shift, sir. So it cannot handle the circuit. mana streaming na lage अपना है मतलब HDMI वो मतलब क्या है कि स्ट्रीमिंग तो आपका लैपटॉप किस तरफ जाना